last type of number that you're going to encounter most often is going to be decimals. Decimals kind of come last because, honestly, you guys are probably already pretty familiar and comfortable working with decimals. But there's a few things about decimals that you may not be familiar with or that comfortable with. So that's what Chapter 5 is all about, okay, is we're going to start looking at working with decimals and decimal applications because, honestly, in most applications, decimals are the more commonly accepted or commonly used forms of numbers just because they're easier to work with, honestly. Fractions are important for a lot of reasons, and knowing how to work with them is important, but in actual applications, typically we'd use decimals. There is a relationship, though, between decimals and fractions, right? Because decimals are really just another way to represent a fraction. And so in the decimal system, right, so you have your place value system. So like, here you've got, over here's your whole numbers, right? So this is like the ones, the tens, the hundreds, and so on. And then down here, right, so where does it start on the other side of the decimal? The first place value is the what? The tenths, right? So it's all base 10, right? Our number system's all base 10. So the first one is the tenths. There is no oneths spot. The oneth spot is just the ones. So it's the tenths, then it goes down to the hundredths, the thousandths, and so on, right? The 10,000ths. And so it's kind of like a reflection of the whole numbers. It just goes down by factors of 10. Yeah? Okay. So when you see a number in decimal form, so like as an example, if we had like 0.2, well, how much is that? So it's 2 tenths, right? So it's 2, and the place value that it's in is in the tenth spot. And so this is equivalent to saying 2 tenths, right? So you can actually pretty easily convert decimals into fractions. You just pay attention to where the decimal or where the value sits, like what place value it sits in, and then you can just translate it back into fraction. Now that one actually is reducible, right? So in this one, those are both divisible by 2. So that would become what? 1/5, right? So every number has at least 2 ways to represent it. You have the decimal form, and then you have the fraction form. So they're just 2 different ways to represent the same quantity, right? True? Everybody okay with that? Do you agree? And you can check, right? Because you could check if 1/5 was the same as 0.2. How could you see if that was true? What could you do? How could you find out if 1/5 was actually the same as 0.2?
Type in 1 divided by 5.
Yeah, you can just pull out your calculator and do 1 divided by 5. And then what is it going to spit out?
0.2.
You can check it, but it's true, right? Go 1 divided by 5, it'll spit out 0.2. Okay. So converting, I want to make sure that you should be able to convert between the two, between decimals and fractions. The fraction to decimal is actually the easier way because, like you said, you can just pull out your calculator and turn them into decimals. Going the other way from decimals to fraction, sometimes a little trickier, but as long as you remember the place values, then it's not too hard. So I'll show you a couple more examples. So let's convert, decimal. Man, I just really want to write an F. Let's convert decimal to fraction. Now that one was pretty straightforward because it was just a 2 in the tenths place. You may have multiple values behind the decimal. So let's say that we had, for example, the decimal 0.48. Okay. So how would you convert? So 0.48 is a little less than half, just under 0.5. How would you convert that into a fraction? Yeah, so the 4, you could think of this as like 4 in the tenths place and 8 in the hundredths, or you could just think this is 48 in the hundredths place. right? You can read that as 48 hundredths. And so what you do is you just look at, okay, where does the decimal end? What place value does the decimal end in? And wherever the decimal ends, whatever place value is, that's where that becomes your denominator. So you take all of the numbers and you say, okay, that's 48 over 100 because my decimal ends in the hundredths place. Yeah. So that's the way you take decimals and turn it back into fractions. Just find where the decimal ends. That's going to be your denominator. And then you should always check, though, because this is reducible, right? Yeah.
Just to clarify, so if it was just 0.4, then it would be 4 over 10, correct?
That's right. Yeah, you don't have to go. You could go further, like you could write as 40 hundredths, but it's just going to get reduced down.
Okay.
Yeah, so you just go to wherever the numbers end. All right, so 48 over 100. That one's reducible, though, because both of those are divisible by what? At least 2. So you can start there. If you divide by 2, that'd give you 24 over 50. But then that would also reduce, divide by 2, 12 25ths would be the fraction. Okay, so 0.48 is the same as 12 25ths. Now, there's a really easy way to check if you did it right. That's the nice thing about this, is that you can always know if you did it right. Just pull out your calculator and calculate 12 divided by 25. And if you pull it out and do 12 divided by 25, what do you get? 0.48. Okay. So that's the nice thing. It's always easy to check. All right? Questions about that example? So you just look where it ends. If you have, let's do another example. Let's say, just to see some other scenarios, let's say it was like 0.015. So let's say there's some zeros in there and some other numbers. What do you think you would do with that? I want to convert that to a fraction. So yeah, so first you just look at first you figure out, okay, what place value does the decimal end in, right? And where does it end? Yeah, this whole thing is sitting in the thousandth spot. So I know that my denominator is going to be 1,000. And then you just take all the numbers ahead of that and you put it over that. So it doesn't actually matter that there's some zeros in there. You just take the values. 15 over 1,000. And then that's reducible because those are both divisible by what? Yeah, so we could divide by 5, And so you'd come up with 3 out of 1,000 divided by 5? 200, yeah. So it'd be 3 over 200. And the nice thing is like I said before, you can pull out your calculator and check what is 3 divided by 200. It'll come out to 0.015 in your calculator. So you can know that you got the answer correct. All right? Okay. So far, so good? So just figure out what place value it is, boom, that becomes your denominator. What about if you had, what if I wanted to take a number like 2.78 and turn that into a fraction? There's actually 2 ways you could do that, but what's one way you could do it? Anybody got an idea how you handle that when there's a whole number involved? Yeah, so one way is you could just know that this is equivalent to a mixed number, right? Because the whole value isn't going to change, right? 2 isn't going to change, and then where does this thing end at? Yeah, the decimals, it sits in the hundredths place, so it'd be like 2 and 78 hundredths. So that would be one way to do that. Now that 78 hundredths is reducible because those are both divisible by at least 2. So 78 divided by 2 is 39, and 100 divided by 2 is 50. Yeah. Yeah. And I don't think that reduces anymore because 39 is just divisible by 3 and 13, and 50 is not divisible by 3. So that would be a perfectly reasonable answer. If I wanted an improper fraction, how would I turn it into an improper fraction? Well, 50 times 2 is 100, and 100 plus 39 is you could map it backwards to an improper. So you can, in this case, if it's a whole number, it's almost easier in this case to put it into a mixed number and then map it back to an improper. But you could actually have started with an improper, because you could say, well, I know my decimal is rooted in the hundredths, right? And you can just pile up all the digits on top of that. So it's 278 in the hundredth spot. So you could write that fraction as 278 hundredths. And then you could reduce that. That's reducible by 2. And then that would get you 139 over 50, which would then turn into 2 and 39 fiftieths. So it actually doesn't matter whether you start with a mixed number and go to improper, or start with improper and go to mixed number. It'll work both ways. All right. What questions do you have on that one? Any questions at all? No? Seem pretty straightforward? Okay. So, working the other way is, like I said, it's actually a little bit simpler. And so let's say we had, if I want to go from, let's convert the other way. Let's say if I want to convert, say, 5/8 to a decimal. So how would I do that? Well, literally it's just what? 5/8 is just what? Remember, fractions are just another way to denote division. Yeah, so if you're trying to take a fraction and turn it into a decimal, you can just do the division. Try 5 divided by 8, and what do you get? 0.625. Yeah. So fraction to decimal is not really that bad at all. Okay. The only problem with going to fraction to decimal, see, if you have a decimal, you can always turn it back into a fraction as long as the decimal ends, because then you know what place value to put it in. But we have certain fractions that don't really translate that well into decimals because, for example, if you try 5/9, right? So that's literally 5 divided by 9. Well, what's your calculator spit out? Yeah, 0.5555 dot. So it goes forever, right? The 55555. It's because our decimal system is like base 10. Everything's powers of tens, but ninths don't translate to tenths. Okay, and so what happens is, so there's multiple notations here. So if you have a repeating decimal, one notation you may have seen is the 5 with the bar over it. That's an acceptable answer. But typically speaking, most of the time, we would just take that number and we would round to some, place value. And I think I've had you round on some of the quizzes. Is that true? I don't know if we've done any rounding. Okay. Oh, okay. Maybe not. I thought maybe we had. But if you're going to round, so let's say I want to round this to the nearest, say, hundredth. So sometimes we're forced to round to the nearest hundredth. Okay, so then you've got this decimal. Okay, well, first off, you need to go find the place value you're trying to round to. So the hundredths is the second decimal. So what's the rule for rounding with decimals? Yeah, what you do is when you're rounding, the first thing you do is you look to the right of the place value that you're rounding to, right? And then the rule is that if it's 0 through 4, then you round down, or in other words, you leave the number the same. And if the number next door is 5 through 9, then you round it up. Okay. That's the idea. And the reason, the rule, it's because it's telling you which number you're closest to. So 5 and above, if the next decimal place is 5 and above, you're actually closer to 0.56 than you are to 0.55. So you round up, and then you just drop the rest of the decimal places. So this 5 should be rounded to a 6, and then everything else gets cut off. All right? So you're always looking next door to determine what to do with that place value, but then once you determine what to do with that place value, everything beyond it just disappears. Okay. All right. Let's try another one. Any questions about that one? Okay. So typically speaking, if I'm asking you to convert fractions to decimals, it'll either be a decimal where it ends, it's a nice decimal, or if it's a situation like this, I would tell you what place value to round to. Okay. So let's try another one. So let's say let's convert, convert 1/3 to decimal and round to the nearest thousandth. Okay, so first off, you just do the division to get the decimal form, but 1/3 ends up being what? Yeah, throw it in your calculator, right? 1/3, 1 divided by 3. It's just going to be 0.33333333333, whatever. So you could write that with the bar notation. It's just that the bar notation is pretty useless if you want to turn around and use that decimal again later. So then we just rewrite them with a rounded form. So the thousandths is how many decimal places? Thousandths is how many? 3 decimal places, right? Because it's tenths, hundredths, thousandths. That means that my final answer should have 3 decimal places. But where do I look to decide what to do with that number? I look next door, and so next door there's a 3. So what should that do? It should stay a 3. And then everything else beyond it gets dropped. All right. Okay. Let's try another one. So let's convert. Let's do an improper fraction. Let's say we had 110 out of 13. Let's convert it to a decimal, and then I don't know if this one's going to be round or not because I just made it up. But if you have to, let's round to the nearest hundredth if we need to. Okay. So first step, if we're trying to convert the fraction to decimal, is we should do what? Yeah, just pull out your calculator, right? Okay, so then you say, so you pull out your calculator and you do the division. 110 divided by 13, it tells you it's what, 8.64?
4615.
Oh, it's 46?
8.46.
Oh, okay, I got that one backwards. 8.4615 dot. Okay, right? Doesn't actually matter what's beyond that because we're going to be rounding to the hundredths, so that'd be 2 decimal places. And so I just need to figure out, okay, here's my hundredth place. So I look next door, and it says, okay, should that stay a 6 or should it go up to a 7? It's going to stay a 6 because it's a 1 next door. So my answer would be 8.46. All right. Any questions on that one? Okay. And then if you have a mixed number, there's 2 ways to handle mixed numbers. But let's say we had, let's convert, say 2 and, I don't know, how about 8/15? Well, there's 2 ways to handle that. So one way to handle that would be to do what? So what is my final answer going to look like? We might need to round this one, I'm not sure. I think this one might not need rounded. We'll see. So what do you do? Yeah, so one way you could do it is you could turn it improper. Is you could say, okay, well, 15 times 2 is 30. 30 plus 8, this is 38 over 15, which is 38 divided by 15. And then you pull out your calculator, and what does it give you?
2.5333.
The 3 repeats?
Yeah.
Okay, so let's round this one to the nearest hundredth or something. Let's just go hundredths.
Okay. Let's go ahead and round to the hundredths. So if we're going to round this one to the hundredths, right, then that's the hundredth spot. You go next door. Should that stay a 3 or should that get rounded up? It should stay a 3 because the one next to it is a 3, right, because you're always looking next door. Yeah? What's another way we could have done that? Can you think of another way we could have done that?
Could you just left the 2 and then do
Yeah, I know that my answer is going to, because I already know what my whole number is 2. So I know that my answer is going to be 2 point something. And so you could just look at the, you could just take the fraction part, right? And you could just say, okay, well, 8/15 is 8 divided by 15. You plug it in your calculator, it's 0.533333, right? So, which we would round to 0.53. And so then we know our answer is going to be 2.53 because we already know what the whole value is going to be. We just got to figure out what the decimal side is going to be. So then you can kind of skip the improper step and just go straight to the fraction part. So either way, though, it's fine. I really actually should be using this sign. Do you guys know what this little squiggly line means?
that's like about.
Yeah, so that little squiggly sign right there, it means about or approximate or approximately. Okay, and anytime you round, you'll see this notation because it's just identifying that that's a rounded number. That's not actually the exact answer, right? 0.53 is actually a different fraction. That's 53 hundredths, which is not actually exactly the same as 8/15ths. They're just very close to each other. And so the approximate sign just lets everyone, hey, we didn't measure this number, we rounded it. Okay? All right. Seem okay? Everybody all right with that? All right. So if you're going decimal to fraction, you just got to figure out where that decimal ends, and then you put it over like the tenths, hundredths, thousandths, whatever is appropriate. If you're going the other way, it's a little bit easier. You just do this. You just actually pull out your calculator and do the division. You may just end up having to round because not all fractions translate nicely into decimals, and that's why we round. Okay. All right. Let's see. What if you wanted to? Let's try this. One thing that's nice with decimals. Let's go back to black. Let's say is if you're trying to like compare numbers. So let's say we have two values. I don't know, like let's try 2 9ths versus 7/30ths. So which one of those bigger? There's actually two ways we could do this. One way is we could find a common denominator between 9 and 30. Like, so for example, we could take those both up to 90ths. But most people don't love fractions that much, surprisingly. And so what's another option we could do? Yeah, we could just turn them into decimals, and we could say, okay, so 2 9ths, that's 2 divided by 9, which is what? Yeah, the 2's go on forever. 7/30ths, 7 divided by 30, what does that come out to be? Pull your calculator out and tell me what you get. 0.23, and the 3's repeat?
Yeah.
Yeah. And so how do you determine which decimal is bigger?
The one that has the bigger numbers.
Yes.
So obviously the 2.333.
Yeah. So what you do is you go place value by place value, right? So they're the same in the ones. They're the same in the tenths, but right here is where you see the change. Right? And so then you go, okay, this one's bigger, So that means that 7/30ths is the bigger number. Not by much, but it's bigger. Yeah? Okay. So if you have a situation where you're comparing decimals, you just go place value by place value until you find a difference. And they might be really similar up to a lot of place values, but as soon as you hit a place value where they're not the same, you go with the one that has the bigger number in it. Sorry, Steve. Okay. Another time that dealing with decimals makes life a lot easier. So let's say, for example, let's say that a waiter made let's say a waiter made $255 in a night. And let's say that, say 3/5 of which came from tips. Right? So then my question is, what amount came from tips? Yeah, so, well,
Or could you just turn the 3/5 into a decimal?
yeah, that's the thing. So you have options, but a lot of people like decimals. Okay, so essentially, what we're trying to figure out is, well, what is? Well, I'll even write it a little. I want to. Essentially, what question are we trying to answer? We're trying to figure out what is 3/5 of 255. That's what we're trying to figure out. Okay, so what do you need to do to calculate? If you're trying to calculate a fraction of a number, how do you calculate that fraction? Anybody know? So I'm trying to calculate a portion of a number, and I know the portion by fraction. So how do I turn that into? There is a number, and let's just say we'll say round to the nearest cent because that's kind of how money works. Okay. So what do? Fraction of a number. So divide by 5 is part of it because 3/5. I mean, there's a division by 5 right there in it. So this is a key word actually in math. Yeah, of is a key word in math. Of almost always tells you multiplication. So if you're trying to find a fraction of a number, then what we're really saying here is what number, and is also a key word. This is something we'll talk about more later. Is in math means what? Of means multiply, but is another key word, which almost always means what? Equals to, right? So it's almost like this is like, what number we don't know is 3/5 of 255, right? So ultimately, yeah, what we do is if you want to calculate a fraction of a number, you just take the fraction times the number. Now, how do you multiply a fraction by a number? There's multiple ways to do it. This is where it's nice to have decimals involved, because 3/5 could easily be turned into a decimal. So if you do that, right, if you convert this into a decimal, what does it become? This one should be 0.6. So one way to do it is to just calculate 0.6 times 255. So you convert it into a decimal, but then you multiply it by the 255. Okay, and then what does that come out to be? 153? Is that even? Okay, so then we don't even have to round this one. So there you go. So if you want to write a fraction of a decimal, then you just take the fraction times the decimal. Now, is there another way we could have done that? I probably wouldn't ask unless the answer was yes. But does anybody know what it is? Trying to raise all this. Anybody know? Almost got it all. It's harder when I'm looking over here. There you go.
You do 355 divided by 5, and then plus that times that by 3.
Yeah, so, exactly, because what happens is if you're multiplying a fraction times a whole number, like we know how to work with fractions, right? You know, the 255 is really like 255 over 1. You know, there's kind of like this hidden 1 there. So what you end up doing is you end up doing 3 times 255, and then you divide by 5. So 3 times 255, that's going to give you like 700 and something. 765. And then if you divide that by 5, well, that's going to give you 153.
Could you also just do 255 divided by 5?
You could.
51 or whatever, and then divide the times that by
Exactly. Yeah, you could do 255 divided by 5 and then multiply by 3. Yeah. The main takeaway though here is no matter what order you do it in, if you're trying to multiply a fraction by a whole number, you just multiply the number by the numerator and then divide by the denominator. You know? So whatever order you want to do it. If you want to divide by 5 first and then multiply, that's fine. If you want to multiply then divide, then that's also fine. Okay. And doing it this way kind of comes in handy. I'll show you when. So like, what if I say, what is 2/9 of 156 or something like that? And let's say round to the tenths. Okay. So here's the deal. I want my answer round to the tenths, but what's going to happen if we try to turn 2/9 into a decimal? What happens is, 0.2222, right? You get all of these 0.22222s, right? And so you could do it directly from your calculator. Like you could let your calculator store that. But what happens is like, what if you round this right now, right? See, if you round too early, then things might get a little messed up. So like here, say that someone did that and they chose to round to the tenths right then. And they said, oh, this is 0.22 times 156. What do you get as your answer if you do 0.22 times 156?
12.32.
Is it 12? What was it?
Oh, wait, 1. No, I get it wrong.
I was going to say it should be 34, 34.32,
Yeah.
like that. Okay. So, and that's okay. Now, if you do it the other way, though, this might not make a good example, but, right, I was telling you what you can do is you can do 2 times 156 and then divide by 9. So 2 times 156, that's like 312 divided by 9. And what do you get if you do it that way? 34 point, is that what it is? 666 dot dot dot. And if you round that to the nearest hundredths, what happens? It's 34.67. So why are my answers different and which one's more correct? The second one is more accurate. The second one's more correct. Why?
Because you rounded the total to that.
Yeah, see, in this one, I didn't round initially. I just did my multiplication, 156 times 2. No need to round there. Then I did my division by 9, and then I can round. What happened here is that if you turn this into a decimal, and then you round too liberally, well, you rounded, this is not 2/9, right? This is something close to 2/9, but it's not 2/9. So then if you take this, so basically there's an error. You make an error every time you round. And so if you make an error by rounding, and then you multiply it by a big number, then the error gets like blown up. And so this is why it's better, if you can, to not round until the very end. Because this is the right answer, and this is not the right answer. And it happened because you rounded too much too soon, and then you multiply. Now, could you get around that? Like, what if you would have saved, what if you would have done this calculation right here, and kept, try that, try 0.222, if you keep a lot of decimal places, times 156, what do you get? 0.22222, like keep a bunch of twos.
34.666.
Yeah, 6663 or something, right? It's like that. And then how does that round? That rounds correctly. So the point is you can do the fraction to decimal conversion. It's okay, that's fine. But what you need to make sure to do is you need to make sure to keep a whole bunch of place values until the end. Because the sooner you round and the more you round, the worse your answer is going to be. It's going to get off by some factor because of that error that's getting sort of blown up by the multiplication. Does that make sense? Yeah. So the moral of the story is, if you do it this way, you don't have to worry at all because there is no rounding until the end. If you do it this way, it's fine. Just keep 5, 6 decimal places till the end, and then you can round at the end. But the less you have to round, the better, because it'll sort of just expound on itself.
That way you use the squiggly sign.
Yes.
In that situation, you're basically interpreting the number.
Yeah, exactly. Because at this point, I should have really written an approximate sign. But this is an error I see people make a lot. Is they say, "Oh, round to the tenths," so then they make the conversion and they round that to the. Oh, I said tenths. I did hundredths in my example, I guess. Oops. But they'll round that to the hundredths, but then it gets blown up later because this actually is not 2/9. But this is literally 156 times 2 divided by 9, times 2/9. So this is a more accurate calculation. So. But yeah, that's why you put the squiggly sign there, so people understand that it's a rounded number, and it's not exact. So, yeah, and that's really why fractions kind of suck, but they're also a lot more accurate in a lot of ways than decimals. So you can get a lot more precise with a fraction than you can with a decimal. All right, the only other thing I wanted to mention, so you can calculate a fraction of a number by either turning the fraction to decimal, and sometimes it doesn't matter because 3/5 turns into a nice decimal. That was no big deal there, so there's no rounding at all, so we're good. You just have to be careful because rounding error can occur. And then the other application of decimals that they start looking at in this chapter is working with circles. Okay. And the reason that decimals become really important when you're working with circles is you have this value called pi, right? So what's the significance of the number pi? Does anybody actually know what pi is? So most people know what its value is, or about what its value is. So you get this number pi. Okay, it's a Greek letter. So you get this number pi, and everybody knows that pi is about 3.14. And I'm writing that approximate thing on purpose because pi is not exactly 3.14, because what's true about pi? Yeah, the digits in the decimal pi go on forever, and they never, ever, ever repeat. It's not an arbitrary number, though. What pi is, so here's the thing about circles. Circles are defined by a couple things. So you have, in a circle, you can have a radius. Okay, so a radius is like a
a half width of a circle. So, and that's usually called, we usually call that r. Okay, so in a circle, the radius is like half, is the width or the distance from the inside of the circle to the outside. Okay, that's the radius. And then you have the whole width across, and that we usually call d, and we call it that because it's what's called a diameter of a circle. Right, so you have the radius of a circle, that's like a half width. You have a diameter of a circle, that's the whole width. And then there's another value that's sometimes measured, which is if you start at one point of the circle and you go all the way around the circle, you walk all the way around it, and you get back to where you started, that distance around is something we call c because it stands for the circumference of that circle. Okay. So like circumnavigation of the globe, it means going all the way around. Like where you started, go all the way around, come back. The circumference of a circle, it's a perimeter, in other words, right? So the circumference is actually the perimeter of the circle. Because the perimeter is the distance around a shape. We'll do a little bit more not much geometry in this class, but we'll look at a little bit of geometry here and there. So anyways, so the number pi, the reason that pi is sort of recorded and written down is because pi is a special relationship. If you take any circle and you divide the circumference by its diameter, you'll get the value of pi. So it's not like an arbitrary number that people made up. Okay, it's like if you took that clock in the back of the room and you measured the distance around it, and then you measured the distance across, and you took the distance around and divided by the distance across, you'd get 3.14. And it works for any circle. So like if you took my water bottle and you measured the distance around it and got the circumference, and then you measured the width of it, and you took circumference and divided by width, you get 3.14. So it doesn't actually matter how big or how small the circle is. That ratio between the circumference and the diameter for every single circle, it always comes out. You can do it to the wheel on your car. Go measure the distance around the wheel of your car, the width of the wheel on your car, and divide the circumference by diameter. I guarantee you'll get 3.14. It's guaranteed. Do it for the globe. You do it for the world. Right? It doesn't matter how big or how small the circle is. It's fixed. Right? If you take the miles around the globe and the distance across the globe and you divide the circumference divided by the diameter, you'll get 3.14. So it's a number that occurs naturally when you're working with circles. That's why it's important. That's why we try to approximate it as close as possible. And then there's a couple formulas. Okay, so this is actually, you can do a little bit of algebra here, and the fact that that's true tells you that you can actually calculate the circumference of a circle by taking pi times the diameter. So that's one formula that we'll use. So you can find the circumference by taking pi times the diameter of a circle. Another one is if you're trying to find the area of a circle, you can take pi times its radius squared. Okay, so these are examples of formulas. Okay, that means they're always true. Okay, those are always true. So if you have any circle, you don't have to necessarily measure the circumference of the diameter or the circumference of the area. As long as you know the diameter or the radius, you can calculate the circumference or the area of a circle just using the formulas. So I'm going to give you an example of that. Okay, so let's say that we'll take the clock for example. So let's say that you have a clock with a diameter of, I don't know, that clock looks like it has a diameter of about, say, 14 inches.
and I want you to calculate the circumference and the radius, and the area, sorry. So a diameter, you have to pay attention to whether or not you're given a diameter or a circumference. Okay? So diameter is a full width across. Now the nice thing though is that if you know the diameter, you also know the radius and vice versa. Because a diameter is just two radius put together, or the radius is just half the diameter. Yeah, so if I know the diameter is 14, then the radius has to be 7, like you said, yeah, 7 inches. Okay. So when you're working with circles, you need both, because for the formulas, for one of them you need the diameter, and for one of them you need the radius. So you need to pay close attention in a problem. Okay, if I'm given a radius, I could double that to get the diameter, but if I'm given a diameter, I can half it to get the radius. So then we're just using our formulas. So I'll copy them over here. So the circumference is pi times the diameter. Then for pi, we typically approximate it. Like you guys all says 3.14. That's true. And technically, actually, we should now use an approximate symbol. So for pi, we can use 3.14. Diameter is 14. What does that come out to be?
43.96.
What's that?
43.96.
43.96. What's the units here? Inches. Remember, circumference is a distance. It's the distance around. So it'll be measured in inches. So then if we go to area, area is pi times r squared. So for pi, we use 3.14. The radius, we figured out was 7. So order of operations, what should we do first here? Exponents. Yeah. So first we need to evaluate 7 squared. So 7 squared is what? 49. Then we can multiply by 3.14. And what does that come out to be? Say that again. 153.86. Now what's the units here? Almost. So areas are always measured in square units. Why? Because we double. Why are the area units always squared? So a line is one-dimensional, right? You're just traveling in one direction. But an area is what? An area is two-dimensional, right? So a line is just like how far you travel across it. An area is like how much you have to cover in 2 dimensions. And so it's always squared. Actually, and the reason why is because there was unit. We didn't keep track of it. But see, in the circumference, pi has no units, but 14 did. It was inches, right? And so in our calculation, it came out to be inches. But in the area, we squared 7, right? It was 7 inches times 7 inches. And inches times inches is how you get inches squared. So you can think of it too as intuitively, it's always squared because you're in two dimensions with area. But the real reason is because with the units, you can see it here. You're doing inches times inches, and so you should be in inches squared. But the important thing is to remember that if you're dealing with the area, your units should always be squared. But these formulas right here, these never change. These are always true. Those are fixed. But based on the size of your circle, your diameter and your radius will change. But once you know one, you can find the other, and then you can find both of those quantities. Okay. Okay, that was kind of a lot for the day. What I'll do is I'll just pass these out, and then you guys can maybe take a look at these today or tonight before you go back tomorrow. And then tomorrow we will review some of the decimal stuff and the circle stuff, and that's what we'll go over then. Before we go on to some other stuff about decimals. All right, and I will see you. You can work on it for 5 minutes if you want. Or actually, I think we're almost out of time. Yeah, you can sit around and work on it for 5 minutes if you want. Otherwise, I'll see you tomorrow.